We're going to be looking at metamorphic rocks, and we're trying a slightly different style of presenting the notes. This is our last rock type. And metamorphic rocks are produced by heat and pressure. Now, it turns out that there are two different types of heat and pressure, excuse me, three different types of rocks that come from these. One comes from heat alone, one comes from pressure alone, and one comes from having both heat and pressure. And by far the most common one here is the one that comes from heat and pressure, which is called regional metamorphism. And from heat alone is called contact or thermal. Thermal, admittedly, is a much easier name to remember. Unfortunately, it is not the most common name. Contact, by far, is more common. From pressure alone is known as dynamic. And we're going to get into comparing and contrasting these different types of metamorphism. However, before we do that, a little bit about metamorphic rocks themselves. Metamorphic rocks recrystallize. Let's try to be consistent with color here. Boom. They recrystallize when exposed to heat and pressure. And that is that the minerals inside change. They rearrange. They recrystallize. And so, close enough there. It didn't let me fix this. And so you end up with new minerals as a part of this process. Made out of the same material as the original minerals, of course. Original rock is also known as parent rock. Often looks different from new metamorphic, also known as daughter rock. And usually there is no melting. Usually there is no melting with metamorphism. As a side note, if we end up with melting, then we start to form molten rock or magma, and we're looking at forming new igneous rock instead. It's not to say that heat and pressure can't result in melting. It's saying that if the heat and pressure causes so much change to the metamorphic rock that they end up melting, then it's not actually metamorphic rock anymore. Anyway, getting into the different types of metamorphism. We're going to start out with the most common one, which again is the regional. And regional metamorphic rocks are usually found over large regions, like mountain ranges, especially at the cores of mountains. Hence the name regional. Pressure here comes from both deep burial. Let's try that again. From deep burial and from tectonic, think earthquakes and plate movements, activity. Heat comes from friction, which comes from the pressure and the different things that cause the pressure. And these rocks are very layered. And layering in metamorphic rocks is called foliation. And with foliation, you usually end up with the pressure coming from one direction. In mountain building, a lot of times you end up with pressure coming in from the sides. But here in the diagram, I'm going to draw pressure coming from above from, say, deep burial. And what ends up happening is as the pressure pushes down, of course, the rock feels squeezed both by what's underneath of it and this weight on top of it. And you always end up with foliation or minerals here getting stretched out perpendicular to the direction of the pressure, so that they end up layering like that. And a lot of times you end up with banding of light and dark minerals. And the minerals that are involved there, excuse me, gives us different grades of foliation. And so we start out here on our list with shale, which is sedimentary. And then we get more foliated as we go down the column here. And so then it's not going to there we go. That's good. Here we get into metamorphic rocks, slate, phyllite, schist, gneiss, which is spelled with the silent G and not at all what you would think. And then last a migmatite. And this is partially melted and getting out of the metamorphic range. As a side note, if I have my way, my headstone, when I do pass, will be a migmatite boulder. I just love the way that migmatites look. They have a very fascinating history, and I really want a pretty rock and to even teach the geology of that rock for my headstone. If I really have my way, I will have a bronze plaque on the back that actually explains the history of the rock that is there on the site. So anyway, that's that. I really like migmatites, and that one there should be a P. I don't know why it recognized it as the division sign there, but anyway. These here are slightly foliated. And these here are highly foliated. And I missed one on my list, I realized, which is why I had the long pause there. Underneath the shale, the sedimentary rock, we should have slate, the metamorphic child of shale. Which it is not like me writing there at all. I apologize. There we go. So slate goes in there in between phyllite, which it's still messing up, and schist and gneiss. Rewind, please, if you need to catch how to spell those, because the recognizing my handwriting thing is not going so well right now. Anyway, less common types of metamorphism include contact, metamorphic rocks. Recall, these are the ones that come from primarily heat. These rocks tend to be non-foliated. Usually confined to local areas. And usually come from nearby hot or even molten rock touching or coming into contact with surrounding rock. And this process forms something known as a aureole. I apologize. I don't know that I know how to. Let's redo that. Aureole. It's going to have a heck of a time recognizing that. Hey, it did. Yay. Anyway, and frequently with the Oriole, we have baked rock surrounding igneous rock. And so the igneous rock here is comes in as, say, an intrusion, intruding upon the surrounding rock layers, and it heats up the rock that it's passing through, no matter what type of rock that was, and the heat, where it doesn't melt, causes reformation, recrystallization of the minerals, and we get a contact metamorphic rock. And the last type that we have is the dynamic metamorphic rocks. And these come from extremely high pressures in fault zones. They are very localized. They do not surround large areas at all. And usually they have had unstable minerals, which then were more easily recrystallized. One thing that you'll hear sometimes associated with certain tectonic events is something called shock quartz. And shock quartz is a great example of this, where the quartz just in a very small region. I mean, you can have rocks containing the mineral quartz that are shocked right next to rocks containing the mineral quartz that are not shocked. But shock quartz is an example of the stressed dynamic metamorphism. Anyway, lastly here we're going to look at some parents of metamorphic rocks. And so sandstone, a sedimentary rock, tends to form quartzite. Limestone tends to form marble. Shale and low-grade coal can form anthracite coal, a high-grade coal. There are some who won't classify anthracite as a metamorphic rock, but it's gone through enough pressure changes that I would say it's more metamorphic than the other coals for sure. Shale also, especially if it does not have a lot of organic material in it can form schist. Nope, it forms not schist. Excuse me, it forms slate. Wrong S word. There. Slate can also form phyllite. I just tried to merge my stuff. I apologize for that. Anyway, you can ignore that arrow there. Phyllite then leads to... This is just horrible. My bad. Phyllite then leads to schist. This is where schist comes into play. Schist leads to gneiss. And granite can also lead to gneiss. And so up at the beginning here, we had sedimentary rocks. I'll highlight the sedimentaries here in yellow. And then those formed metamorphic rocks. You know what? Let's be consistent with earlier. I was writing about metamorphic rocks in purple. We'll highlight in purple. And again, shale can form both slate and phyllite. But now, here notice, we have phyllite leading to schist, schist leading to gneiss, and there's gneiss again coming from igneous granite. And so, recall earlier we had our grades of metamorphism, and we said that shale, a sedimentary rock, slate, and phyllite were not very foliated. But then schist and gneiss are very foliated. And so you can imagine a situation where we have a slate and heat and pressure starts being applied to it, and it turns into, or excuse me, we have a shale, heat and pressure is applied to it, and it turns into a slate. And then that slate continues to experience heat and pressure and becomes a phyllite. And that phyllite continues to experience heat and pressure and becomes a schist. And that schist continues to feel heat and pressure and becomes a gneiss. And we have these steps that are leading from one rock type to the next, and also a process here where on our rock cycle that we talked about a while ago, we are going from metamorphic rock through heat and pressure back to metamorphic rock. We are ending up with a loop here of one rock forming the same rock type. Of course, we see with the yellows and the granite here that we can have other rock types, igneous and sedimentary, both through heat and pressure form metamorphic rock. But the rock cycle is not a straightforward cycle the way that you were taught in the past necessarily. Anyway, that finishes the notes over metamorphic rocks. Be sure if you have any questions that you shoot me an email, leave a comment, or come see me in class.